Hello class, welcome to Algebra Lesson 9.2, which is all about solving quadratic equations by factoring. By the end of this lesson, you should be able to find the solution of a quadratic equation by factoring. All right, let's talk about example 1, using the zero product property. So, fun fact, I kind of introduced this to you guys already back in what I called old chapter 10 or chapter 9 part 1. This was the equations portion. And what I did was I showed you how you could factor things and have them set equal to 0 to solve for real and extraneous answers. So if you felt really good about that, good news. This lesson is going to be pretty similar to that. There's some new stuff, but for the most part, pretty similar. And if that lesson was really tough for you and that was something that maybe still doesn't make a lot of sense, this is another lesson to help you better understand how to solve these quadratics, okay? So, using something called the zero product property. If we think about, just before I even read the question, zero product property. Okay, so zero obviously means the number 0. Product means that you're multiplying. So anything times 0, it doesn't matter if it's 10, that equals 0. It doesn't matter if it's negative 15 times 0, that equals 0, right? So that's the zero product property. And the reason that's important is because if we look at this equation, so we have this factored equation already. We have x minus 9 times 5x plus 2 equals 0. Now if we think about it, if we plug a number into either of these equations, or not equations, sorry, parentheses, say I plug 1 in. Let's just pretend I plug 1 in. If I plug 1 into the first one, it becomes just a regular number, right? It becomes a negative 8. If I plug a 1 in here, it becomes a 7, right? So these parentheses each just represent a single number. So the point of the zero product property is to get one of these parentheses to equal 0, because then it doesn't matter what number the other one is, 0 times any number equals 0. Okay, so that's why you take each of these sets of parentheses, so in this case x minus 9, and I set it equal to 0, and then I take my other set of parentheses, which is 5x plus 2, and I set it equal to 0. So now I go like this, and I say, okay, I'm going to move the 9 over by adding, so x equals 9. And then if I go over here, I'm going to say minus 2, 5x equals negative 2. Divide both sides by 5, divide both sides by 5. X equals negative 2. Wow, that's not what I meant to write. Let me try that again. X equals negative 2 fifths. Now, technically, if you trust the process and you think that, yeah, I did that with no calculation errors, and I trust you, Miss Johnson, I want to move on, tough luck. I'm showing you how to check. So if I plug a 9 in, you can see I would have 9 minus 9 times 5 times 9 plus 2. And I want to see, does that equal 0? So 9 times 9 is 0. So 0 times 5 times 9 is 45 plus 2 is 47. And 0 times 47 is 0. So I know that 9 is the solution that works. If I plug negative 2 fifths in, I have negative 2 fifths minus 9 times 5 times negative 2 fifths plus 2. I want to know, does that equal 0? Well, this right here, that's negative 9 and 2 fifths. Okay, or negative 9.4. And then this right here becomes a negative 2 plus 2. That's a terrible 0 I drew. So I have negative 9.4 times 0. Because negative 2 plus 2 is just 0. So I know that negative 2 fifths also gives me 0. So this is also a solution. So the way that you do zero product property, if it's already factored, you just take the first sets of parentheses, set it equal to 0, solve. Take the second set of parentheses, set it equal to 0, and solve. And those are your two solutions. Sometimes there's one solution. That's just how it works, okay? I want you to go ahead and try what are the two solutions for this problem. Good luck. All right, for this problem, hopefully you ended up with x equals 1/2 and x equals -3. You can see my work right there. I took the first set of parentheses, 2x minus 1, set it equal to 0, and I solved. And then I took the second set of parentheses, which was x plus 3, set it equal to 0, and solved. Okay, so that is how you would get 1/2. All right, let's look at example 2, which is where you are practicing how to solve by factoring. So you were asked, how can you use factoring to solve x squared plus 9x equals -20? Well, you learned how to solve once it was in factored form, right? That's what example 1 was. So now we're just going back one step further to see if you can do that first step. So we have x squared plus 9x equals -20. And when you're solving these equations, you always want them set equal to 0. So that means I'm going to add that 20 to both sides. So add 20 to both sides. I now have x squared plus 9x plus 20 equals 0. You always, always, always want your equations equal to 0, okay? Now I want to look and see, okay, I'm looking for two numbers that multiply to 20 and add to 9. So for 20, my factors are 1 and 20. Those don't add to 9. 2 and 10, those don't add to 9. And 4 and 5, those do add to 9. So this would become x plus 4, x plus 5. And if you switch the order and put the 5 here and the 4 here, it's the same thing. Okay, so that's the first step. Now I'm going to do the same thing that I did on the last example. I'm going to say x plus 4 equals 0, x plus 5 equals 0. So x equals -4, x equals -5. And those are my two solutions for this problem. Okay, hopefully that's not too bad. Remember, I was looking for two things that multiply to my last term and add to my middle term. All right, now it's your turn to solve by factoring. Good luck. All right, for this problem, hopefully you started by moving the 64 over using subtraction, and then you looked for what two numbers multiply to a -64 and add to a -12. I started writing my factors and realized that a -16 and a +4 would multiply to a -64 and add to a -12. So then I wrote x plus 4, x minus 16, and then I solved them. I said x plus 4 equals 0, or x equals -4. And then I said x minus 16 equals 0, or x equals 16. So that's how I got those two solutions. Okay. Example 3, let's use factoring to solve a real-world problem. A museum vault has an outer steel wall with a uniform width of x units. The area of the museum vault ceiling and the outer steel wall is 1,664 feet squared. What is the width of the outer steel wall? Okay, so I know that this here is 20, and then there's also x units here, and there are also x units here. So that tells me that that's going to be 2x plus 20 to get the width across. And then to go the other direction, the length, I would also have x units here, plus 40. So I'd have 2x plus 40. And if I'm trying to find something with area of a rectangle, I'm going to do length times width. So I'm going to multiply those two values together, and they're going to equal 1,664 units. And if I multiply those two, 2x times 2x, that's 4x squared, plus 2x times 40 is 80x. Then 20 times 2x is 40x. And then I have plus 20 times 40 is 800. All right. And then if I simplify 4x squared plus 120x, I forgot to write equals 1,664. And then I subtract that 1,664 over. That would be negative 864 equals 0. And if I think about this, well, all of those numbers are divisible by 4. They all have a GCF of 4. So if I divide everything by 4, I'm left with x squared plus 30x minus 216 equals 0. Always look for, are they all divisible by something? In this case, they were all divisible by 4. And then from here, now I'm looking for what multiplies to a negative 216 and adds to a positive 30. So I have 1 and 216, negative 216, and then 216, that would be 2, and oops, I clicked the wrong button on my pen. All right, and then it'd be 2 and 108, negative 108, sorry, a 3 and a negative 72. None of these are adding up to 30 yet. Then I have 4 and 54, a negative 54, that doesn't add to 30. I have, or sorry, these are the numbers that should be negative. The smaller numbers should be negative. My bad. All right, and then if I do, it's not divisible by 5, but I think it is divisible by 6. So if I do 216 divided by 6, I get 36. So a positive 36 and a negative 6, that would multiply to negative 216, and it would add to a positive 30. So I can change this to x minus 6, x plus 36 equals 0, x minus 6 equals 0, x plus 36 equals 0, x equals 6, x equals negative 36. Now here's something to watch out for. When you are talking about a real world problem, and usually for these it involves area of something, or distance of something, okay? So the length, remember lengths and distances, they can never ever be negative. So when you solve something like this and it's talking about the length of something and you get a negative answer, that is the number that you can just kind of throw out. So the width of the outer wall would just be 6 feet. And that would be my final answer. So I would say 6 feet. Okay, because distance can never, ever, ever be negative. All right, and then our last type of example, we're talking about using factored form to graph a quadratic function. So if I give you a graph, I want you to be able to tell me what the equation is for it in factored form. And this is probably going to sound scarier than it is. First of all, the equation should equal 0. And if it's factored form, you're going to have parentheses. I'm going to go like this. I know I have to have an x and an x, or a variable and the variable repeated. So x and x, y and y, m and m. Ooh, m and m. Now I want M&Ms. Sorry. I'm like squirrel right now for attention span. Anyways, you can see what you've been solving for all night is actually wherever it crosses the x-axis. Okay, so here it crosses the x-axis at negative 2, and then here it crosses at 3. So the key is you always write x minus, and then in this case, x minus a negative 2, that just becomes x plus 2. And then you have x minus a positive 3. So that would stay just like it is, equals 0. And if it's asking for factored form, you get to stop right there. Okay, so you find these values, where does it cross, and you put them in. X minus the number, it equals 0. If it only touches in one spot, let's say we had something that looked like that, you would have x minus, let's pretend that's 5.5. You would go like this, and that would be your final answer. That's all you would do if it only touched in one spot. But the example I gave you touches in two spots. It touches at -2 and 3. So I write x plus 2, x minus 3, and it equals 0. If it does not specify standard form, it wants you to FOIL that back out. So it would become x squared minus x minus 6 equals 0. Okay, so if you were to re-multiply those two things together, this would be your equation. Okay? So I want you in factored form to write the equation for this function. Good luck. All right, hopefully for this problem you saw the graph crosses at a +3 and a +9. So you say x minus 3, x minus 9, set it equal to 0, and you call it good. All right, here is your concept summary. For those of you that like to take screenshots of this or add this to your notes, feel free to do so. If you have any questions at all, please don't hesitate to ask for some help. I am happy to help you. Have a great day.